Hello everyone, welcome to CS281. This is a backup copy for lab number 1. In this course, during the labs, we are going to teach you the tools that you will going to use in your project, starting with how to draw ER diagrams. So if you look at the website, basically the project has 5 different stages. For the first two design stages, you are going to design your database and you would like to show it with an ER diagram. And to draw that ER diagram, we are all going to use this software called Draw.io. It is a software to drawing general diagrams, but we are going to use it for drawing the ER diagram. For the upcoming stages of the project, we are going to use Libreoffice base. Previously, we were using Microsoft Access, but it is no longer provided by the university. So we are adapting an alternative free solution. And in the final demo as well, we expect you to design and implement a database. So we already gave you some project descriptions, and that database is going to solve the problem given in that description. In the upcoming weeks, we are also going to give you some scenarios, and during the final demo, we would expect you to show those scenarios. So it could be like login as a user, add a student, add a course to the student, etc. And when the time comes up, we are going to see more details of it. During the labs, it is better to follow what I'm doing, try to do it on your own computers as well. Therefore, for the upcoming weeks, it is a good idea to install LibreOffice Base. We have some descriptions that tell you how to install LibreOffice Base on your computers. It is available for different operating systems, so for Windows, Mac, Linux, etc. You can install it, and this guide is for Windows operating system, but it is also applicable to other operating systems as well. And it is like a basic setup. We are going to use the long-term support version. Currently it's 6.4.6, and we would like to use the English version because in the translated versions some of the keywords are also translated, which makes it difficult to be on the same page. We are going to use the English version, and if your operating system is a different language, there are like a couple of steps you need to take to install the English version. So other than that, this is a basic installation of the LibreOffice, which is a full package. It also includes the base, which we are going to use for creating databases, starting from lab number 2. And another stage maybe you need to take is installing JDK, because the database makes use of it, and it is also explained in this document. But in this lab we are starting with Draw.io, and only in this lab we are going to talk about it, and you are going to use it in design stage 1 and design stage 2. And possibly in one homework you might need to use Draw.io. And it is a really useful tool, even if you are not drawing ER diagrams. Maybe for some other project you can use this tool as well. So when you go to the draw.io, it's an online tool. There are also offline versions, so the desktop versions are available in this link if you look at our website. But the online version is sufficient. When you go here, we will start by creating a new diagram. And if you look around, there is also an ER diagram template in here somewhere. But there are some different kinds of ER diagrams, and the version that we are using is not following that template. So if you maybe search around, you might find it somewhere. I'm not sure where it is, but what you need to be careful about is there are several different kinds of ER diagrams. It is trying to achieve the same thing, but there are little differences. And to be on the same page, we are going to use a common one that is introduced in the lectures. Because if you switch around, if you try to mix and match different versions, there will be some problems about the arrows, etc. We are going to look at it. But because of that, we are going to use a blank diagram here. It is what I would like to say, basically. So I'm going to create this. And since this is not my first time creating a diagram in Draw.io, it did not ask me to save it where. It is automatically trying to save it on my computer, but there are some cloud saving options as well. So I'm going to name it as Lab1, and the extension is going to be Draw.io. So lab1.draw.io is my file name. And if you choose cloud saving options, it is again a similar thing. So I'm going to save it. I can like anytime rename. So it is saying if you need the desktop version, you can get it from here. So the file options are very similar to other software. You can like save it as a different file, and you can also open Draw.io files from your cloud sources or from your device as well. So if I don't have any diagram right now, let's create something and then save it, maybe to example to make more sense. I have some general shapes here, and if I click any one of them, it will create that shape in my workspace. And if I click on any of the shapes, I can move them around with my mouse. I can left click on one of the shapes and drag it around. Also, while a shape is selected, you will see blue dots around the shape. And those dots you can use to resize your shape. There is also an option to rotate your shape. If you click on this rotation arrow, it makes a 90 degrees rotation, or if you click and hold it, you can rotate it by 5 degrees. I guess you can set these intervals in the options somewhere. I guess it is sometimes by 1 degrees. So the rotation is most of the time we are going to use it with triangles to create an is-a relation, and we just need to click on this arrow 3 times to make it the equilateral triangle in the upright position. Additionally, for each of the items, while the item is selected, if you write something on your keyboard, it will type that in the center of that item. And whenever you resize that item, carry it around, that text will stay there. To change it, you can double click on the item so that you can edit this text. For example, I can write student here. But for now, the shapes are not correct, right? In the ER diagram, we have some special symbols. So you can drag your mouse with the left click and hold it to choose multiple items. You can hit the delete key on your keyboard to delete those items. You can right click any of the items and choose delete as well if you want to delete the items. So we have this handout for this lab, and in each handout we have sometimes we have some descriptions for you to read it in your own time. So in this handout, basically we are summarizing each of the different items that you can have in your ER diagram, followed by some tutorial-like steps that prepare you. Like in case you missed this lab, these stages should give you some information about what's going in this lab, how to do the basic stuff, etc. And in the beginning of this document, we also have an ER diagram made in Drawio. And if you already know Drawio, and if you are going to be able to draw this ER diagram, that's okay. Then this is the thing that we are going to learn in this lab, to be able to draw this in Drawio. And if you generally talk about ER diagrams, we are basically, with a database, we are basically storing some relational data. If we wanted to just store data, we can use a list of items. But for these items, we would like to retrieve the items in different ways using queries. And we also would like to relate some of the items with other items in other lists. That's why we are using a database. And to talk about the structure of our database, we are using ER diagrams. In ER diagrams, we show entity sets using rectangles. So the entity set is like users that we can store, or students, courses, etc. Maybe we are storing cars. In that case, we are going to have a car entity set. And for each of these entity sets, we store different attributes, and we use ovals for showing attributes. And we are going to have our entity sets with multiple attributes, and we connect them with simple lines. So I have an entity set here named user. I have ID, surname, name, and password that I store for each user. So if I would like to store a user, that user is represented by 4 different attributes. I need to store 4 different attributes for that user. And the attributes that we underline are the primary key. There could be a single primary key, or multiple attributes could create a composite primary key. In this case, there is only one primary key, which is ID. So far, let's try to replicate this in Drawio. So I have this basic rectangle. If I click on it, it will bring it in my workspace, and I would like to write user on top of it. And since it's kind of big, you can resize it to make it a more comfortable size. In here as well, I have the option to zoom in and zoom out. And if you click and hold the space key on your keyboard, if you drag the mouse around with the left button, you can go around in your workspace. Let's bring the user here. Now I would like to include some ellipses. If you click on this ellipse shape, it will include it. Let's say this is going to be, if we look at it here, let's say this is going to be the name. And I will again resize this item in a better size. Now I need simple lines. Between the entity sets and attributes, there is always a simple line. In the further stages, we are going to also see some arrows, in some different positions, but between the entity sets and attributes, it is always a simple line. I'm going to click on this line, and with all different kinds of lines, we have a starting and ending point. So with this item, I see them as different blue dots. So if I click and hold this dots, I can carry the different ends of the line. There is also a blue one, which is not that visible in the middle of this line. If you mistakenly click there, it will create an arc. So in between those dots, you can use them to create arcs. But we are not going to need them in our lab. So you can undo or redo your operations using these keys, or under the edit menu you have also those options, and also the Control Z and Control Y hotkeys. So what I want to do to connect these items is choose one of the ends and carry it in the center of that item. So there are also, if you look carefully, there are also some anchor points in the corners of the items. You can also connect them there, but if you are using these anchor points and if you move your items around, it might go over the shapes. So it is better to connect these lines to the center so that it automatically makes it look better. So if I carry them around, since they are connected from the center, I have no problem with overlapping. So most of the time, when you have your first items, you can just duplicate the existing ones to make your life easier. So I can right click on the name, the name attribute, and choose duplicate. The hotkey is Ctrl D to duplicate that item. For this one, while it's selected, I'm going to write surname, and I also need another line. I'm going to choose this line, Ctrl D to duplicate it, and connect these ends of this line to user and surname. I also need another attribute. Let's write ID for it. This time, since it's the primary key, I would like to underline it. And in the right toolbar, I have the text option. So if the shape is selected, I have different options for color, etc. We are not going to use color in our IAR diagrams. I have the option for text, and I can choose the underlined version. Or if I double click on the text, it will only show the text toolbar, and in here as well, I can underline my item or my text. Let's duplicate one of the lines and connect them between ID and user. And I also need a password. Let's duplicate one more, write password here, carry them around, duplicate one more line, and connect the items. So this is the same for any size of a diagram. We then have relations. Let's say we have a bunch of users, a bunch of courses, and in between those entries of different entity sets, we can define relationships. So for example, in here it's given for a teacher teaches courses. For a teacher to teach a course, that teacher should exist and the course should exist, and basically we are pairing different entities of these two different lists, let's say, together. Let's say I have a list of teachers, lots of teachers there, list of courses, and I would like to relate one teacher with one course. In such cases, we are using relationships. And we show it by diamond shape. So if we come back here, I'm not going to specifically draw it for the same thing. Let's say users attend courses. Let's duplicate the user. I'm going to write course here. Let's say for courses we also have IDs, but let's name them as CID for course ID. I'm going to duplicate another line and connect them between course and course ID. Let's get one more attribute, and I'm going to say course name for this one. So it is going out of this item, so I'm going to resize it basically and duplicate another line to connect them between course and course name. Now I need my relationship. Here's the diamond shape. If I click on here, it will bring the item. Let's say enrolled for this one, and let's resize it in a better size, because if the items are too big and the text is too small, that's hard to fit on the same page. Basically we have, like, if you zoom out, we have pages in here as well, and you are not going to print out your documents, but if it is with small text and very big items like this, it doesn't make very much sense. So it is better to keep a better size, a good size that you decide. So between entity sets and relationships, there could be also simple lines. I'm going to, for now, connect them with simple lines. Sometimes people, or let's first say this, okay. Between the entity sets and relationships, there could be simple lines, there could be bold lines. We are going to talk about it in a minute, but if you choose a line under the style, there is an option for the width. You can make it thicker. This is also valid for any of the items that you position. In case you need, for example, weak entities, etc. We are going to talk about them. But for any of the shapes here, you can make them thicker. Be aware of it. And also for the lines, you have an option for the starting and ending points. So for example, for now, I'm not sure which side is the starting point, which side is the ending point. But if you click here, you can include arrows for one side. So in this case, it was in the correct side. But if it was, so for example, if I click on here, include an arrow here, this arrow is on the wrong side, and I can right click on the line and choose reverse to reverse it. So when we are talking different styles of ER diagrams, in the notation that we are using, if there is an arrow, that arrow should be next to the relation always. There are, in the different notation, the arrows are pointing towards the entities, but in our notation, the arrows, if there is an arrow, it should be next to the relation always. So a mistake that people might do. Another mistake is putting an arrow between entity and attribute. So this is wrong. This is also wrong. There should not be any arrows between attributes and entities. You can also connect attributes to relations. That's okay. So in that case, I'm going to have an attribute, for example, here. Maybe that user is enrolled to the course, and let's say we are storing the grade for that course with the relation, because the grade is not an attribute of the course. That course can be taken by, let's say, many students. In that case, you should not store that grade in the course. And that student, if we make this as student, might be taking lots of courses. In that case, we are going to store the grade when that student is enrolled to a course. And what these triangles or arrows might mean, you already seen it in the class, I guess, but with the tick line and the normal line, the tick line is about participation. If you have an tick line on the teacher side here, that means that all the teachers should contribute to this relationship. If there is a teacher, that teacher should teach, not cheat. If there is a teacher, that teacher should teach some course. Which course, I don't know, but there should not be any teacher that doesn't teach a course. That's basically what we are saying with total participation. If you have it on either side, on both sides, let's say, you are also saying that each course should be taught by a teacher. There should not be any courses in the corner that nobody teaches. And the arrows are about cardinality. One-to-ones, one-to-manys, many-to-manys. If you don't have any arrows with the relationship, then that you are saying that this is a many-to-many relation. A teacher can teach many courses, and a course could be taught by many teachers. In our example, if there is no arrow here, you are saying that every student can take more than one course, many courses, and in every course there could be many students enrolled, which is the usual case. You are allowing one student in here to exist multiple times in this relationship, and you are also allowing a course to exist multiple times in this relationship. If we have arrows on both sides, then that means that one teacher can teach one course, and one course could be taught by only one teacher. In this case, this is a one-to-one relationship. In our case, if we had the arrows, let's choose a line, and for the line starting point, let's put the arrow. Let's put the arrow for the other line as well. And remember, if it is reversed, you can right-click on it and choose the reverse to put it on the correct side. The arrows should always be next to the relationship in our notation. In this case, you are saying that one teacher can be enrolled to at most one course, and one course could be enrolled by at most one student. And you can mix and match cardinality with the participation constraints. In this case, if I make this line thicker, then I'm saying that, okay, each student should be enrolled to a class. And how many classes a student can be enrolled to? It is only one. In this case, I'm saying that each student should be exactly enrolled to one course. On the course side, I'm just saying that each course can be enrolled by at most one student. So there can be some courses in the corner that nobody takes, but each student should take exactly one course. That's what I'm saying. If I include the tick line on the other side as well, then I'm saying that, okay, there cannot be any courses in the corner. All courses should be enrolled by students as well. So let's for now revert them back to the original one, which was one-to-one. Oh, sorry, which was many-to-many. And on some occasions, we can have one-to-many relationships. In that cases, sometimes people make mistakes about how to read the relationship. So one-to-many relations, we have an arrow on one side and a simple line on the other side. And which side is the many? Which side is the one side? And you might look at this picture for like remembering it correctly. So let's say we have the owner and a bunch of dogs. And how they are related is through the leashes. And if you think it as the relationship in the middle, if you draw a vertical line here, then the leashes are kind of like an arrow. So the arrow, the dogs are here, the arrow is from dogs towards the relationship with the owner. And in here you can read it as the owner can have many dogs, but for a dog there can only be one owner. So the owner can appear so we can read it like in two different ways. You can read it like that. The owner can have many dogs and the dog can have only one owner. But in the future, we are going to talk about also how to implement these relationships. And those relationships are implemented as tables. So when we go into base, LibreOffice base, we are going to see that for entity sets, we are keeping tables. And for relationships as well, we are going to also keep tables. We are going to store our data as tables. And on those tables, let me like open Paint and like show a simple example here. With these ones, let's say, I'm keeping them like here. For owners, let's say I have a bunch of owners. Sorry, I was not ready for using the mouse. I didn't plan it, but let's for now use it. So for the relation has, I'm going to keep a table. Let's say these are the primary keys of my owners. For the has relationship, I would like to relate one owner to a dog, let's say, and like some hard letters to represent differently. I'm going to have a list for the dogs as well, and let's name the primary key of dogs with letters ABC. In this case, let's say I would like to relate owner 1 to dog A, And owner 1 could also own dog B. And let's say owner 2 should have, let's say this list goes on. This is going to have the dogs F and E, let's say. In this case, if you look at the table, the owner can appear multiple times in this table, in such a table. And in such a table, the dog can appear only once. I cannot have any other B here, because otherwise I'm assigning B to a different owner, which cannot work in such a case if we have such a constraint, saying that an owner can have many dogs, but a dog can only have one owner. At most one owner in this case, because we are not saying that there is total participation. There are some dogs without owners, but if that dog has an owner, there can only be one owner for that dog. In this case, this is what we are saying. Basically, what I try to say is, based on how we read it, the dog side could be like the one side if you look at here. So it is better to think it in a sentence. In the table, the dog can appear once in the relations table. But let's leave it aside. We are going to see it again when we create our tables and relationships in base. So we can have total participation and one-to-many, many-to-many, one-to-one relationships together. And we have a bunch of examples here. And sometimes the same relation could relate different instances on the same entity set. So let's say there are teachers inspecting other teachers. In those cases, we are going to use the same entity, the teacher entity, twice for the same relationship. And in here, let's say we have another relation, let's say friend of, for example. And let's say we are using this to indicate that a student is the friend of another student. Then in that case, if I connect one line from the centers of these relations, of this relationship and the entity set, then for the second line as well, if I connect them in the middle, then they would overlap, which is seen as just one line. In these cases, we would like to use the anchor points, so I can use the bottom and top anchors to connect my lines. So it is easier to disconnect this line and then connect it to the anchor point to be able to see those lines. And sometimes you might leave the line without connecting as well. And when you carry around your shapes, that makes it difficult. So it is always good to keep your lines connected. Now, in such cases, the roles of the related entities could be different. In the inspect case, one side is the inspectee, one side is the inspector, for example. In such cases, for the friend of, you don't really need such constraint. But let's say the friend request comes from one side to the other side, and you might want to give meaning to these lines as well. So if you choose that line, you can start typing something and it will put it there, from and to, for example. In some cases, we have ternary relationships. That means the relationship is connecting three different entities. So let's say teachers are teaching courses in different classrooms. In those cases, we might assign the classrooms also in the relationship. And all of the cardinality and participation concepts are applicable to this one as well. So in here, while a student is enrolled to a course, it could use a classroom, for example, and in that case, I can also have an additional entity set connected to the relationship. And that entity should have some attributes as well. Like let's say room ID and also maybe the floor number, which is this time not going to be the primary key, so I would like to remove the underline since I copied it from here. There is underline. But if I choose text and choose this underlining symbol, then the underlining will go. And there is also this typo, right? If I double click on the text, I can click again and edit my text. So other than ternary relations, there are also aggregate relations. With an aggregate relation, we are defining a different relation based on an existing relationship. And in this case, let's say, again, we would like to combine teachers with courses. And for some of the courses, let's say they are online. And for some of the courses, we are going to use the classrooms. In such a scenario, using a ternary relationship is not that good because, like, let's say for lots of courses, we don't have any classroom. Then we are going to have nothing stored for this class. We are going to have null values in the table of this relationship teaches. If we use a ternary relationship, then we are going to have teachers and courses for for all of the lines. And for most of them, let's say we don't have a class. The class is null. And for some of them, we have certain classrooms. In such cases, using an aggregate relationship makes more sense because we are teaching in this relationship. Teachers are teaching courses in using this relationship, and the assignment of classrooms is a different relationship. And in that relationship, which is called in this case, with this in relation, we are defining this relation based on the relationship named teaches. So we are not giving classrooms to the courses and not to the teachers as well. We are giving classrooms to a teacher that is teaching a course. And to show an aggregate relationship, we use dashed rectangles. So we are going to have just one relationship within the dashed rectangular area. And you can think it as an entity set now. So these relations are similar to entity sets in terms of how they are related. This is one entity set, this is another entity set, and I'm using a relation to relate entries in those. So let's come to our example. Let's say I don't want to use a ternary relationship anymore. Let's click on this line, click on delete. Let's say I would like to make an aggregate relationship. Again, I'm going to use rectangles. And you should realize that each new item that I bring from this toolbar is going in front of the existing items. So there is some sort of layering system going around. And you can right click on any of the shapes and send them to front or back. This time I'm going to send my new rectangle to the back, and I'm going to make it large enough so that it contains the relation of interest. So within the aggregate relation, there should be only one relation, and you should also include the entity sets that are related with this item and the attributes of those entities. And in this case, I'm not going to include this other friend of relationship within this rectangular area. And this rectangular area should be a dashed one. So I'm going to choose this item, and then on my side menu or this toolbar, let's say, we have line properties. So remember, we were making it thicker using this option. And there is also an option for dashed lines. So I'm going to choose dashed line for this new line. And one thing you might need to be aware is that when I make my last item dashed, for example, if I create a new ellipse shape, that ellipse shape would follow the same style as well. So in such cases, make sure that you correct it to the one that you want to use. So once you change it, all the new ellipses are, or all the new shapes are using the simple line. So now I would like to use another relationship. Let's click on enrolled, Control D to duplicate it. This time let's say in. So this is not the teacher case. So in this case, maybe it doesn't make that sense, but for showing showing how to use the tool, so I'm going to have this line connected to the bigger rectangle shape, which is dashed, and I can connect the other one using the similar way. I can have arrows or nuts, I can have tick lines. It is similar to the basic relationships, with the only difference that instead of using an entity set for one of the sides, we are using the relationship, and we never connect the relationships directly together, so this is wrong. Instead, we use a dashed rectangle around that relationship, which also includes the entity sets that are connected using that relationship. So if this was, for example, a ternary relationship, I can as well have something like this. Maybe an entity set A with some attributes B, etc. This is also possible. A ternary relation can be used as an aggregate relationship. We also have a special kind of relation called is-a relation that defines a hierarchy. Let's say we have users. User is the parent, and all the children of this parent is going to also inherit the attributes and the relation capabilities of the parents. So let's say if this user is making some relation, then that means teacher can be in that relation as well, student can be in that relation as well, staff can be in that relation as well, because it will inherit all the capabilities of the user, of the parent, and also all the attributes of the parent. That's why in this special case, for children, we do not show the primary key explicitly, because the primary key of the user is going to be used as the primary key of the children as well. And to show an is-a relationship, we are using equilateral triangles. And let's do it in this case. I will click on the triangle. So remember, I need to turn it around. Either you can go to the arrange, and in here there is angle. You can click on this button to rotate it by some degrees, or put an angle here, or click on this rotation symbol. If you click and hold, it makes arbitrary rotations, and the text is also sometimes rotated. So let me show it with a new item. Let's say I bring a new one, I make an arbitrary rotation, write something here. Let's say I'm trying to make it the correct rotation, and then the text is also rotated with it. The other thing is more useful if you bring the item and click on the rotation arrow a couple of times. When you write the text, it is the correct alignment. The text is horizontal. So this is what we need. And I can write is-a here. Maybe it's better to write it on the second line, like you can hit the enter key to make it go one line down. And let's say in our case there are different kinds of students. So this is my is-a relationship. I will make it kind of smaller. And let's say there are different kinds of students, then I will connect again with a simple line. The student to this is a relationship. The parents should be above the triangle. So I should have only one parent that is on top, on the above side of this triangle. And I can have lots of children, and those children should be below the triangle. So different kinds of students, I don't know, maybe like based on the level or the class of the students, etc. Let's say level 1. I'm going to duplicate it. Let's say level 2, etc. And with is a relation, we don't have arrows. We just use the simple lines again. And if I have an is a relationship, I should have some sort of difference between the children. So if I leave it like this, then I don't need to use the is a relationship. I can just include one attribute to the student, saying the level of that student. So why not just include the level as an attribute of the student? Most of the time, if I'm using an is a relationship, then that means between the different children, there's some sort of difference in terms of the attributes or the relationships. Let's say there is also a level 3. And if I leave it just like that, then that means that I can store it as an attribute of the student as well. There is no difference in terms of attributes or relationship capabilities right now. But if I say, okay, for level 2 students, we are giving scholarship. So I need to store the scholarship amount for level 2 students. And let's say there are some companies in our database. So let's say for each company, I also store a company ID and also a company name, CNAME, let's say. I'm going to duplicate my existing lines, connect the attributes of the company, and let's say level 3 students work at companies at the same time. So I'm going to have a work relationship, but on one end I'm going to connect it to the company, but on the other end I'm not going to say students are working. No, not all students are working. Only some students that are level 3 are going to work. So this is saying something about the capabilities of this special type of students, let's say. And using this hierarchy düzgün değilirsek, what we are doing is we are inheriting the attributes of the students in each of these special kind of students. But for level 2 students, there is an additional attribute, scholarship. And for level 3 students, they can work at companies. So if I'm storing a student in this relationships table, then that can only be a level 3 student, not a typical student. We also have weak entities. And weak entities are the ones that cannot be uniquely identified by themselves. So with entities, we are thinking about objects, a list of objects, and consider an object type that you cannot uniquely identify by itself. It should belong to something or somebody to identify it uniquely. So for example, in this example, there are loans, and customers are borrowing these loans. And for each loan, we are keeping the amount and the date. So think that we are the bank and we give loans to different people. And on the same date and with same amount, we can give money to different people. And in this case, we are saying that, okay, loan is a weak entity that can be identified by this borrower's relationship. So this can sometimes be referred to as the weak relationship as well. So to identify a loan, it should be in this relationship. And therefore, we need total participation on loan side. So if a loan exists in our database, then it should be given to somebody. And how we identify is through that somebody that we give this loan to. So for a loan, we identify it by the CID of the customer plus date and amount of loan. And in such cases, we need to underline these weak keys. So these are partial key attributes. We need to underline them with dashed lines. And let's do it in our case as well. Let's say we are storing the addresses of the students. So I'm going to create a new entity, address, and for each address, let's say we are keeping it simple. We are just storing the city and the street number. Street no, let's say, to make it simpler. In your databases as well, it is better to keep the names simple, so long things don't work well. So these are the attributes of an address. And think about it, in the same city and the same street now, there could be multiple different students. So I can identify students with addresses, and when I need the address of the student, let's say the city and the street number is enough for me. But to be able to choose a unique address, let's say I have student Ali, and when I want to find the address of the Ali, the addresses are listed in a way that will be identified in relation to the students. In such scenarios, we need weak entities. And for these weak entities, I can omit using weak entities if I have a unique identifier for the address. So in the case, let's start with the basic case without having a weak entity. I can have an address ID in here, a unique ID for each of the addresses, and then I can just include a simple relation between addresses and students. Let's say lives at, for example. So I'm saying, okay, students are living in addresses, and each address can be uniquely identified by some primary key, AID. But in this case, I'm storing different AIDs for each of the addresses, which is not like very helpful. Instead, I can do it like this. I can omit the unique AID, because if you think about addresses, if an address exists in my system, that should belong to a student. So that's where this total participation comes from. And let's say that, okay, there is an address and it cannot be belong to two different students at the same time. If that's the case, then we have this one-to-many relationship here. So we are saying that, okay, for a student, there can be multiple addresses if it's possible. So the student can have a main address and like some backup addresses. But for these addresses, it should belong to only one student, let's say. In this case, we have this one-to-many relationship. And this is going to be a weak entity. Therefore, I'm going to make it thicker. This is also the weak relationship that this weak entity is defined on. This is going to be also a thick shape. And for city and street now, to say that these are partial keys, I need dashed underlines. So it was thicker. I'm going to make it thinner. why it was thicker is the last item I changed. I made it thicker. That was why it came thicker. And since there is no dashed rectangle for the text option, I'm going to position this dashed lines under the attributes. So remember, when you click on an attribute, when you are connecting a line, there are anchor points, and I'm going to use the leftmost and the rightmost bottom anchor points to connect my dashed line, so that when I move it around, or if I change the shape of this item, it will fit it automatically. And that's how I will show the partial keys of the weak entity. And like, weak entities are like more rare, let's say. And some false thinking that you might make is depending. So some people do it like this. Some people think it like this. If there is no student, there cannot be any courses. Okay, let's make student then weak. And following the same logic, the student tries to make everything a weak entity. That's not a good approach. So with weak entities, you should think it like this. Can you identify a unique entry for that entity by itself? If you can, then that's not a weak entity. For example, in the case of students, can I identify a unique line, a unique entry for a student by itself without depending any of the other attributes, or not the attributes, without depending on any of the other relationships or entities? So I can find a unique student by the ID itself. But for things like addresses, loans, uh, in these cases, we are not keeping a unique identifier for this entity. The things that we store for that entity is not enough to identify a unique one. For example, in this case, the same amount of loan on the same date can be given to multiple people. And how we identify it is by the customer that borrows this loan. So to identify unique line, we need the CID, date, and amount in this case. So that's going to complete the introduction part of the first lab. And in the other video, we are going to try to implement this example database. In your projects, you are also given the description of a problem or a system, let's say. And we expect you to make sense of the description and draw the ER diagram. And in the ER diagram, these are the items that you might need to use, and like all of them are included here. And this is the way we symbolize one thing that we did not talk, maybe the composite primary key. In this case, you need to underline more than one attribute. And like, using our toolbox in this video is sufficient to draw any ER diagram you need.